Hello, my name is Mohamed Lamin Diahate, and I'm about to perform on Lab 3. So let's just open my Lab 3 file, which is right here. So we had to build different circuits, namely the program.ram dig, the 4-bit rec dig, brandless, and the CTR, which is an incremental basically. So first of all, we're gonna open the 4-bit rec dig. So basically, what this circuit does is just output the input D over here if you enable and press the clock button. So let's just simulate it and see. We have our input is 0 right here. If you enable, press clock, the output is gonna be 0. Let's just change it to A, let's say. So basically, we expecting an output of A over there. If you enable and clock, we just get an output of A over here, over there. So we did export it into a Verilog file. So just gonna go over here. So I'm gonna just open it as a Verilog file. So this is the Verilog file over here, and I will have to um, show my test cases too. So basically, if we have the input as an A1, which means that the clock and the enable are set to 1, we expect an output of A, same over here. But if we have let's say an input of A2, which means that the enable and the clock are set to 0, we expect an output of 0. So let's just visualize it. If we have our input is A, D, or A, which is our 3 inputs, we have the enable, which is on, and the clock on. So we see like every time the clock is 1, we're gonna get an output of A, which was the input 2. So Q, which is the output. Every time the clock is 1 and enable is 1, we get in the output of A. Every time the enable is 1, clock is 1A. Every time the if the enable is 0 and the clock is 0, we're gonna have an output of 0. So that was the first circuit. Next, we're gonna go to our stop the simulation. Next, we're gonna go to our uh the incrementer. So basically, if we enable the circuit and just press the clock button, it's gonna keep on incrementing. It's gonna increment the value over here and send it to the 4-bit rec, which give us an output 2, 3, 4. It just keep incrementing the value. Next, we're gonna have this next circuit, which is the program RAM that dig. So basically, we had our addresses set up already in the hex file, which is right here. I have the text file, but it's the same in my hex file too. So I have the address 0 is 4 and address 1 is 5. So basically, it's gonna give us the data out. If the address 0 is 4, the data out is gonna be 4 also. Let's just simulate it and see. We have 0. So the address at address 0, we had a value 4, which is the output over here. If we change the address to 1, we're gonna have an output of 5, which was our number 1 line over here in the text file. Okay, so after that, we're gonna go to our last circuit, which was the brandless. So basically, what the brandless do is just read, accumulate value, and eventually add values. So over here, if we simulate it, we had um, the data in our hex value. Line 0 was 4 and line 1 was 5. So if we read, pass the value, load it into the accumulator and clock it, we're gonna get an input of we're gonna get an output of 4 because that's the value we had at line 0. So now if we add another value, right? Let's say line 1, which is 5, right? We're gonna have a value of 5. if we want to add those two value, we could just disable the pass button and put the arithmetic, which is gonna give us an ALU out of 9, which is the sum of 4 plus 5, which is 9. And then if we just clock it and clock it again, it's gonna keep adding 5. So right now we have 9. It's gonna keep adding 5, which is gonna give us a value of 14, which is I think in hexadecimal. So it's right here. So basically, that's what the brainless does. Just keep on adding value, and output it into the ALU out. So we had exported into the Verilog file. Added my test cases too. So let's just go to our brainless um, stimulus.v. Open it. So basically, what we have over here, we just first of all we just put it on reset, like nothing is gonna happen. Then we're gonna have to add 4 right here, which is the ALU out um is gonna display 4, which is like just putting 4 into the accumulator. Then after that, we're gonna add 5 right here. So 4 plus 5 is gonna be 9, and into the ALU out is gonna output 14. So that's what we just visualize over there. Let's just see the Verilog file. Let's close this one and open this Verilog file, brandless. So yeah, that's what we have over here. So first of all, we're gonna read. After read, we're gonna pass the value and load it into the accumulator and clock it, right? So if we clock it, if you could see, the output is gonna be on the data bus. We're gonna have 4. And if we add the 4 with the output, with the 5, which was like the input on address 1, we could expect a value of 9 and which is 14 right here. So 9 is going to be the value, and it's gonna, if we clock it again, it's gonna just add 9 and 5. That's basically what it do. So that was the last circuit, and the wave the wave visualization. So I think that was it about lab 3. Thank you.